Hey, happy people, this is Mr. Wilcox coming to you again from my kitchen table. Last week in stats, we were talking about the distribution of the sample mean. Today and tomorrow, we're going to talk about the distribution of the sample proportion. And then we're going to finish the year with the confidence intervals for both. So, just like finding a distribution of the sample mean, finding the sample proportion means we're going to have a population and we're going to have uh, different samples, and for those samples we can distribute our different proportions. So I'm going to pause now so you can write this down in your notebook, and when you're ready, hit play. So the big difference between a sample mean and a sample proportion is a mean we were just, finding the average number of people who did something. Here we're actually looking at a characteristic, and we're looking at the proportion of people who actually have that characteristic in samples. So if our entire population is a homeowners association and we ask all 100 houses how many of them favor an increase in annual assessments, and 65 of them say that they are in favor, then our uh, population proportion, P, is actually our 65 out of our 100. So number in favor over the total number, and that's 0.65. So our proportion of people in favor is 65%, or 0.65. So for a population proportion, you need the entire population and the entire proportion. But remember, in statistics, it's very rare that you can get information from an entire population, and that's why we will do several samples. And so that's why we would have a sample proportion, and we call that p hat. So go ahead and write this down. I'll pause now so you can do that, and when you're ready, hit play again. So a sample proportion, we're going to call that p hat, and it's the same idea. It's how many people in our sample, out of our sample size, actually have a characteristic. So the number of people with that characteristic go on top, our sample size goes on the bottom, and that is how we would find a sample proportion. So the next thing up is an example. All right, so this is a lengthy example, so I'm going to pause here for a second so you can write it down. And then when you're ready, pause the video, and then when you're ready, hit play again. All right, so it says an opinion dynamics core conducted a survey of 1,000 adult Americans and asked, are you currently on a low carb diet? Of those surveyed, 150 said that they were on a low carb diet. So we're going to find the sample proportion of individuals who are on a low carb diet. So we just learned that our p hat takes the number of people with a characteristic over our sample size. So in this case, the number of people with our characteristic is being on a low carb diet. 150 of them said they were on a low carb diet. So 50 out of the 1,000 people in the sample. So if we turn that into a decimal, that is 0.15. So our sample proportion here, p hat, is 0.15. All right, so here's some information about describing a sampling distribution of p hat. I'm going to pause here so you can write this in your notebook. So pause the video, write it down, and hit play again. So when we are looking at sampling distributions of p hat, just like everything we've been talking about lately, we can assume it is normal as long as our sample size times our population proportion times 1 minus our population proportion is greater than or equal to 10. So we're going to have to make sure that that is true, and we can find the mean and the standard deviation. So just like when we're doing any other distribution, we could tell if it was normal, tell what the mean is or expected value, and tell what the standard deviation is. Our mean here is going to be our population proportion, and our standard deviation, we're going to take that our population proportion times 1 minus our population proportion, put it over our sample size, and then take the square root. So here's an example. Again, I'm going to pause for a second so you can pause the video and write it down in your notebook. All right, it says, based on a study conducted by a Gallup organization, 76% of Americans believe that the state of moral values in the US is getting worse. So we're going to describe the distribution of the sample proportion of Americans with this belief if we ask 60 Americans. So if our N is 60. So first of all, we know our N is 60. And another piece of information they give us is that of the American population, they say that 76% believe the morals are getting worse. So that's our P. So we can figure out if this is approximately normal and then find the mean and the standard deviation. So find if it's approximately normal, we're going to take our N, which is 60, times our P, which is 0.76, times our 1 minus P, so 1 minus 7.6, or 0.76, not 7.6, sorry. And make sure that's greater than or equal to 10. And what we get is 10.94 is greater than 10. So that is true. So it is normal. And so our expected value for p hat would be our population proportion, so 0.76. So we would expect that our sample proportion should be somewhere roughly near our population proportion. And then we're going to find our standard deviation for p hat by taking our square root of our p, 0.76, times 1 minus our p, or 0.24, and dividing it by our sample size, which is 60. And if you put that in a calculator, you get 0.055. So to describe our sample proportion, we would say that it's approximately normal. With an expected value of 0.76 and a standard deviation of 0.055. So that would be our description. All right. So that is just a small lesson on sampling distributions and population for population proportion and a sample proportion. So I hope you all are happy. I hope you are healthy, and I hope you all have a great day.